Hi friends, this is Geetansh here, and today I'm going to talk about how to use Apache Spark for transformation on bigger data sets. Before we dive into it, I would like to discuss why we are going to use Apache Spark's own data frames instead of using the more common pandas. Speed is one main thing. Due to its in-memory computation, the speed of Apache Spark is 100 times faster. It also supports batch and streaming libraries where we can easily connect for streaming data. Also, it has higher scalability due to its clusters, and I'm going to show you how to easily set while we can easily use pandas and some standard data frames. Using Apache Spark's own data frames is highly practical when we are dealing with only large amount of data, that is in GBs, with real world productions and for bigger companies. When you're having petabytes of data, it is impractical for using data sets like pandas. So we use Apache Spark as. Let's log in into Databricks for easy setup, and let's use a notebook over there in the community edition. That's free to use for the sake of this video, or you can use the on-premise solution that we have shown you in the previous videos. So let's dive right into the tutorial. So in the first cell, we have initialized the parameters for the PostgreSQL's connection, where in the local host we would add our IPv address, or if it's on your own machine, you can write to localhost. Next, the port number is mentioned 5432, and my database, you can write your database name, and the database username and password can be entered under the quotes. The table name is laptop with capital L, so there are extra inverted quotes, double quotes inside. Be sure to keep this in mind. Now this is the DF in the PySpark data frame type. We are not using Python, as we can scale this with large GBs of data too. We are printing the schema, so we can clearly see that RAM and price are in a string format, which is clearly need to be casted to a integer or float. We have dropped the meta columns by the drop function. Now we have selected a distinct value of RAM, and we can clearly see it was string because of the extra GB and some wrong values of up, which I have filtered out from my database. This is the data cleaning, and it should take the most amount of time for running an ML model, and it should be spent. It's the most amount of time spent by a data scientist. I filtered the other wrong values of RAM and deleted them. I have confirmed the deletion of the counts by df.count. Next, we have casted the correct values of price, float, and screen size. I have used the description for the touch screen as 1 and 0. I have traversed to the different strings, and now I can see the count of the touch screen. I made a new column with touch screen and IPS using the same method of traversing the description column and finding the value touchscreen and IPS. Next, I have checked out the screen size, and there are no null values in this, which is a good sign. We don't need to clean this column. Now we can even use SQL commands like group by, and I can see the different values of resolution. Let's separate the resolution column into X resolution, Y resolution by this cell of code. Now you can see it in my data frame. I've got two new columns, and they do have some null values. These were the distinct values I got in the X resolution. Passed the abnormal value list in the cell and imputed it median values of resolution. Now I've casted the X resolution column as an integer. Now I'm doing the same transformation in the Y resolution column too. I'm going to clean it with the clean the abnormal values with 1080. with the mode frequency, and I'm going to cast it to an integer, the same as x resolution column. Now I can check the correlations with different columns of the price with the price. I made a I combined two features into one: x resolution and y resolution divided by the screen size to get the PPI. I checked the correlations for these PPI too. Now we can drop the screen size, x resolution, y resolution columns. Next we are going to check for the different types of processors. I'm going to take the first value of processor to get the CPU company's name from the processor description from the original data frame column. Now I have assigned the values with if-else statements. I have run the user-defined function, and I have now used a SQL query showing the counts of different types of processors with their processor company's name. So we can clearly see that data cleaning is the most important task and takes the highest amount of time. From the description column, now I'm trying to extract the HDD or SDD type of the storage and how many GBs it is. And I even need to convert the terabyte column to GBs using this cell code. The places where it was not able to find the storage, I have imputed it with 512 GBs of SSD. Now we are going to finally dive into the ML. We can surely do more of the data cleaning, but for the sake of this video and keeping it short, I have not checked out the other columns. Next, we are using MLlib library by the vector assembler in Spark. We have defined the indexers and encoders. We have built a pipeline. I'm using the random forest regressor, and I fit the pipeline. I've done the train test split. This is the general, just like pandas, and sklearn, just slightly different, and the RMSE value is 180. It is better than the original RMSE of 325, which is from the mean value. These are some other functions which I find are useful for the transformations. You can add the serial numbers. You can change this column name. These were some other useful functions. You can obviously use the filter and selection operations and group by function operations, just like the SQL queries. Now we can also push your transformed data frame using the df.write JDBC command into your Postgres database. Now do check out my video on Power BI for the easiest graphical user interface friendly tool to do the same amount of transformations in just a few minutes without code. It is especially useful for small data sets which are not spanning over GBs.